So as we approach the end of chapter 3, we get into some additional topics referred to as permutations and combinations. So I want to show you a little bit about how these can be done on the graphing calculator as well as we move forward into this lesson. So again, a permutation is an ordered arrangement of events. So a key thing we pick up on here is this word ordered. So order does matter with a permutation. So the number of different permutations of n distinct objects is described as n factorial. So the expression n factorial, like I said, this n exclamation point is read as n factorial. The way n factorial works is if I give you something like, say, 5 factorial, what that means is 5 times 4 times 3 times 2 times 1. Some things to pick up on, though, is 1 factorial is 1. Also, we learned that 0 factorial is also 1. So we had some things going on here as we move forward. So as far as the permutation goes, let's look at an example. So the Big 12 is a collegiate athletic conference with 10 schools. Baylor, Iowa State, Kansas State, Oklahoma State, TCU, Texas Tech, and West Virginia. How many different final standings are possible for the Big 12's football teams? So notice that standings order does matter. So what I have to pick up on is how many actual teams are present. Even though it says Big 12, where there are actually 12 teams present. So Baylor, Iowa State, that's 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice how there are 10 teams in the Big 12. So as far as placement goes, order does matter. Since there's 10 teams, there's 10 choices who would be in first place. So I have 10 for that. So after I choose one of those teams, notice that 9 are left for second place. And then after I choose that, then we're down to 8 teams for third place. And that kind of counts down times 7, times 3, times 2, times 1. I'm sorry. Looks like I jumped the gun there, didn't I? Want to get down there in a hurry, didn't I? So let me try that again. So 10 times 9 times 8 times 7 times 6 times 3 times 2 times 1. So we could put that on the calculator, or what we can do is using the calculator, if we hit the math button on the calculator, over here to the right, there's this probability. So if I slide my arrow over using my directional pad under probability, notice that number 4 has got this exclamation point. So if I quit that, so if I want to do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I can do that quickly by just hitting 10 to start with, hit the math button, come over here to probability, and choose number 4 for the exclamation point. So if I hit enter, that'll give me this 3,628,800. So that would be my answer to that problem, would be 3,628,800. So it's kind of weird. There's actually that many choices. So 3,628,800. I think I typed that in correctly. Yeah, we got it. So the catch is sometimes, though, with a permutation, you may want to choose some of the objects in the group and put them in order. Such an ordering is called a permutation of n objects taken r at a time. So in this case, we're not going all the way down to 1. So this is considered, taking indistinct objects and only picking r of them. So let's look at an example that would involve that. So a psychologist shows a list of 8 activities to a subject in an experiment. How many ways can a subject pick first, second, and third? So notice that order does matter in this case because you have this first, second, third concept. So order is mattering. So this is a permutation because of that. So what happens is we pick up on is it's going to be 8 choices for first. And then once we choose one of those, that leaves us with 7 choices for second. And there's only 3 choices for third. So it's going to be 8 times 6 times 8 times 7 times 6. So if I use my calculator, I can go 8 times 7 times 6, and I would end up with 336. Now, if you use the formula for this permutation is n to the p r. So that means you have p stands for permutation, n stands for how many objects are in the permutation, and r represents how many we're choosing. So if we're using the formula, notice how it says n factorial. So notice how in our problem, n would equal this 8, and this r, notice how there's a first, second, and third. There's only 3 spots to order that in. So if you use my formula, this should be like 8 factorial over, on the bottom we have this n minus r factorial. So it's going to be 8 minus 3 factorial, which in turn, this turns into 8 factorial over 5 factorial. So if I play this out using the formula, that would be like 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial would mean like 5 times 4 times 3 times 2 times 1. So if you use the formula, notice that the 5 times 4 times 3 times 2 times 1 are alike on the top and bottom. Notice how that gets me back to this 8 times 7 times 6. So using the formula really gets me to the same spot, 336. So notice I can kind of do it without the formula, 8 times 7 times 6, or if I use the formula, I get that. Now, if you pick up on that this is a permutation, you can also put this in the calculator as 3PR. Actually, I'm sorry, try that again. Our n was 8. So let's see here. So I have 8, and we're going to have p and a 3. So we have 8 distinct objects, but we're only choosing 3 of those objects, and we're trying to figure out how many distinct ways that they can be ordered. So using my calculator, if I hit the math button, if I come over here to probability, PROB, notice that number 2 has this NPR. Now, the way this works, though, is you actually have to type the 8 in first. So if I quit, I have to hit the 8 to start with. Then if I go to math, come over here to the PROB, choose number 2 for a permutation. Notice how it now creates the format, hit 3, hit enter. It'll actually give me the 336 that way as well. So there's many options to do this. The shortcut is if you recognize it's a permutation, you actually can just put it into the formula. But sometimes it's actually quicker if I just recognize that that's just going to be 8 times 7 times 6 and be done with it. So the number of distinguishable permutations of n objects where n1 are one of the type, n2 is another type, and so forth and so on. So let's see what they mean by this. So we have this formula. So finding a building contractor is planning to develop a subdivision. So a building contractor is planning to develop a subdivision. So the subdivision has 6 one-story houses, 4 two-story houses, 2 split-level houses. And how many distinguishable ways can the houses be arranged? So for me, what I pick up on this is we have 6, 4 is, that's like 10. So there's 12 houses being built. So there's 12 objects being built here. So that would be our n. So when I do this using the formula, I have this 12 factorial on the top. Notice how we have 6 one-story houses. So what I can do is put 6 factorial as one of them. 4 two-story houses, notice that's just another type of housing. So there's 4 of those, 4 factorial. And then we have 2 of these split level houses. So then I have this 2 factorial. So what I can do, instead of trying to do that all by hand, I can put that into the calculator. So see if I can pull my calculator up here. So notice how I have this 12 factorial, and notice how we have a numerator denominator. So if I want to, I can hit the alpha button, hit the y equals button, and notice how it has the format for a fraction number 1. So I can type the 12 in to the calculator, use my math button to get to the probability to find that exclamation point. It's number 4. Got that going on. Then if I come down to the bottom, I need a 6 factorial. So 6 factorial would be like a 6. Hit the math button again. Number 4. Then I can do a 4 factorial. So 4, math button, probability of 4 again. Then 2 factorial. And so let's let the calculator do all the calculations for me. You get 4. So I have 12 factorial over 6 factorial, 4 factorial, 2 factorial. So if we enter, that would give us 13,860 different ways to organize those houses. So what do we say there? 13,860. So this would turn into 13,860. So the distinguishable ways of arranging those houses. So it's surprisingly how many different ways you could do that. The next thing we get into is what's called a combination. In a combination, what we pick up on is we're still arranging things, but now order does not matter. So, for instance, I have here an example. In each selection, order does not matter. Like if I have A, B, C, B, A, C, you still have the same letters in a different order. That doesn't really matter. So what we got going on here is the number of ways to choose R objects from N objects without regard to order is called the number of combinations of that. So a combination is when we want to disregard order. So the way we do this is we actually have to remove the duplicates in this problem. So we have a formula here, but let's also see if we can just kind of understand the problem from another perspective. So the manager of an accounting department wants to form a 3-person advisory committee from 20 employees. So from 20 employees in the department. In how many ways can the manager form this committee? So notice how, again, he's just forming a committee. It doesn't matter who he picks first, second, or third. It's still going to be the same people in the committee. So this is one where order does not matter. So notice that you have these 3 positions. So let's see what we can piece together here with this. So if I'm trying to just do this logically, notice that we have 20 employees, but we're only going to be choosing 3 of them. So in the first slot, we have 20 options for the first slot. For the second slot, we would have 19 choices. In the third slot, we would have 18 choices. Now, if I just multiply 20 times 19 times 18, that's going to give me a permutation. But what I want to do is remove the repetition. So what I pick up on here is I have to divide by I have to remove out the repetitions. Since there's 3 slots, what we're trying to do is figure out how many different ways can we rearrange a 20, a 19, and an 18. So what we pick up on, that's just really 3 times 2 times 1 is what that is. So what you have then is this 20 times this 19 times this 18. And since you only have 3 slots, you have 3 choices here, 2 choices here, and 1 choice there. So I have to remove that 3, that 2, and that 1. So what we pick up on is, the 2 would go in 18 9 times, and the 3 would go into 9 3 times. So what I essentially have is 20 times 19 times 3 is what this turns down to. So if I'm just trying to do that without the calculator, a whole lot of calculator, 20 times 19 times 3, that gives us then this 1140, 1140. So that's kind of using my logic. Now, if I just want to recognize, hey, it's a combination, if I want to use the formula, so I have this N would be 20 employees. We're choosing 3 of those employees. What we're trying to do is figure out how many different combinations there are. In other words, without caring about order. So if I do that in the formula, it says you have 20 factorial on the top over then this N minus R, that's going to be 20 minus 3 factorial times then 3 factorial. So on the top, you're going to basically have this 20 times 19 times 18 times 17. We'll just put 17 factorial there. On the bottom, notice that 20 minus 3 is 17 factorial. And then we have this 3 factorial. So notice that the 17 factorials will divide out. 3 factorial is the same thing as 3 times 2. So that gets us right back to where we were. So this is going to be 20 times 19 times 18 over 6, which gets us right back to that 1140. So if I want to do some math. Or again, I can just put 20 factorial over 20 minus 3 factorial times 3 factorial into the calculator. Now, another way to do it is we actually can use the shortcut on the calculator, which is if you have 8 and we want to choose 3, we can actually put this into the calculator as well, and we don't have to do any of that math. So to do a combination on the calculator, we can go to the math button. Actually, we have to put the 20 in first, and then we do the math button. We come over here to probability, and we choose a combination, which would be the 3, and we're choosing 3 of those. Hit enter, and also that also gives me the 1140 as well, without having to do any of the math, just putting it in to the calculator. So that would be how we could put a combination to the calculator. So one last example, if I'm finding the probability of being dealt 5 diamonds from a standard deck of 52 cards. So again, we're talking about probability here. So remember, this is kind of a classical probability. So remember, with the probability of this event happening, the top has to be the number of outcomes in the event, and the bottom number has to be the total number of outcomes in the space. So on the top, what we pick up on is this. So we have to determine the number of outcomes in the event. So the event, what we're doing is we're being dealt 5 diamonds from a standard deck. But how many outcomes are possible from that? So in other words, this is going to be either a permutation or a combination. But notice how being dealt 5 diamonds, order does not matter in which position they're in. So this is a combination. So remember, we got to recall that there actually are 13 diamonds in a deck. So N would equal 13 diamonds in a deck. And we're choosing 5 of those. So that would be 5 on the top. So to do the top, we recognize that there's only 13 diamonds, and we're choosing 5 of those. So that's the number of outcomes for that event. But remember that we have to also determine how many actual outcomes are all together. So remember, we have 52 cards, and we're being dealt 5 cards. So this doesn't happen all the time. So if we look at the bottom, the total number of outcomes is actually going to be, N would actually be 52 cards. But notice how we're being dealt 5 cards. So if we put that on the bottom, 52 choose 5, this will create a probability to this event. So if I can put that into the calculator, so if I hit the alpha button, use the N over D button, so the top is going to be 13 diamonds, and we're recognizing this is a combination. That's number 3. We're only going to choose 5 diamonds. So that's the number of outcomes that we can get as far as the event goes. But how many actual events do we have altogether? Well, remember, we do have 52 cards to deal with, and how many possible choices are there? If we hit the math button, come over here to probability, hit number 3 again, and we're again choosing 5. If we hit enter, this will give us this probability. So notice how we have to move the decimal 4 places to the left. So this is going to be a strange number. So let me see if I can put that down here. So we have this 4.95, and I think we have like e to the -4 over here. So if I move the decimal 4 places to the left, that means I have to put 4 zeros there. So it's going to be like 0.0004995. So a lot of times they'd be rounding to maybe like the 4th decimal place there. So this would be then approximately 0.0005 is what that answer would be. So that kind of takes us through a little bit of using the calculator with problems.